Hello student, today's question is from organic chemistry. We have to identify the dipole moment of some compounds. We have first compound CCl4. So CCl4 is our first compound. This is carbon tetrachloride. Now carbon tetrachloride has tetrahedral structure. So in this tetrahedral structure, the chlorine are, we know that the chlorine are electron negative compounds. So the chlorine present is delta minus, delta minus, delta minus and delta minus. All electronegative chlorine are present in the forehand of carbon, and carbon is delta positive. This carbon center is highly electropositive in nature. Now the dipole moment move this upper direction, and similarly in the 3 chlorine group backward direction. So in this case basically we have to consider that these 3 dipole moment equivalent to 1 dipole moment. So this side the dipole moment cancel out and we get mu equal to 0. NEET mu 0 value we get. So here dipole moment is 0, so it is a non-polar compound. Similarly, our second compound is methyl chloride. Methyl chloride is CH3Cl. So this is also our tetrahedral structure. At first we placed here the tetrahedral form. So the chlorine is electronegative, so dipole moment move the upper direction, and the carbon is electropositive center. This carbon center is electropositive center, and Cl minus is electronegative, so delta negative placed here. We have 3 hydrogen. These 3 hydrogen also electropositive in nature, so its dipole moments move upper direction. All the 3 hydrogen dipole moment its move upper direction. So the NEET vector of dipole moment goes to the upper direction. So its dipole moment value present may be approximate 1.68 dB. So this is our dipole moment value of CH3Cl compound. We have third compound carbon dioxide. Now this is the structure of carbon dioxide. Oxygen is delta negative as a electronegative compound, and carbon present here delta positive. So our dipole moment both side goes this opposite direction. So here cancel out the dipole moment, and here mu value present here 0 dB. Our next compound is SO2. SO2 is triatomic molecule. So structure is bent like structure, and it has lone pair. So it has triangular shape, so its bond angle is 119 degree, approximate 119 degree 5 minutes. So we know that the two oxygen are electronegative, so both side dipole moment goes this side, and our lone pair is also electronegative, so it goes this side. Now this oxygen having the electronegative charge, the value of electronegativity is greater than the lone pair of the sulfur atom. So our net dipole moment goes to this downwards direction. So its dipole moment approximate 1.6 dy is present. Now our next compound is BF3. This is the structure of BF3. Bond angle is 120 degree. Now here also the dipole moment is value is NEET 0 because fluorine is electronegative and boron is electropositive. The 3 fluorine plays the opposite side, so 3 dipole moment also goes the opposite side, so cancel out the dipole moment vector of dipole moment. So here mu value is also 0. In this case, mu equal to E into D. Here D equal to distance between the two compound. So two atom, distance between two atom. So here D equal to 0. That's why our mu value is also 0. Our next compound is NF3. This is not similar to BF3. As here nitrogen and boron contain 3 fluorine compounds, but its structure is like this type of structure. Here nitrogen contains 3 electronegative fluorine compound, so here dipole moment goes downwards. And we have also the lone pair, electronegative lone pair. So its dipole moment goes upward direction, but between fluorine and lone pair, the comparison of electronegativity, fluorine is greater electronegative than the lone pair. So the NEET dipole moment goes to the downwards direction. So its dipole moment value is maybe 0 point something, mu equal to 0.26 dy. So this is our NEET NF3 dipole moment value. Now this is the very important dipole moment question, that we have cis trans isomer. Basically diastereomer have two type of isomer. One is cis isomer and another is trans isomer. We know that. So we have the compound 1,2-dichloroethene. 1,2-dichloroethene. Basically ethene is double bond present here. So cis structure is 2 chlorine present in cis position. This is a cis 1,2-dichloroethene, and another isomer is trans 1,2-dichloroethene. 2 Cl compound placed in anti position. So this is our cis structure and this is our trans structure. Here ethylene compounds as similar as ethylene structure, the cis and trans isomer also having 120 degree bond angle, and it is also sp2 hybridized. So here 2 chlorine placed. At first we talk about the trans isomer. Here 2 chlorine present in anti position. You see that these 2 chlorine present in anti position. So the 2 dipole place electronegative chlorine present in opposite direction, so its dipole moment goes to the opposite direction. So here cancel out its dipole moment. So its NEET mu value is 0 dy for trans isomer, and in this case hydrogen value is negligible. Okay, now talk about the cis isomer. This chlorine 2 electronegative compound plays in same direction, that means upward direction. So we have to consider that our mu value, the vector of dipole moment goes upward direction. So it has the mu value its mu value is very large, that is 1.89 dB. So this is our answer, and this is most important question. This C stance diastereomer type question is most important for dipole moment question. Okay. Our next compound is toluene. Now this is benzene ring containing CH3 compound is toluene. We know that benzene, every 6 carbon contain the hydrogen. So here present also hydrogen. Now in this case, this benzene ring part contain sp2 hybridization, and this CH3 contain sp3 hybridization, because here present double bond character. That's why here this benzene ring present sp2, and this CH3 tetrahedral like structure and present sigma bond. So here sp3 hybridization is occurred here. Now this hydrogen is electropositive, and our methyl compound CH3 compound shows plus I effect. Due to plus I effect, we rewrite the structure. This due to the plus I effect, this CH3 play as an electropositive compound. Electropositive, no, it may CH3 compound shows the electropositive character. That's why its dipole moment goes to the downward direction. And our hydrogen compound is also electropositive. It shows electropositive character, and its dipole moment shows upper direction. But between two CH3 compound and hydrogen, CH3 is more dominating character than the hydrogen, so its dipole moment goes to the downward direction. It has some mu value. This mu value is 0. something 0.68 or 37, this likes value. Now we have the two compound NH3. NH3 means ammonia, and here present NF3 nitrogen trifluoride, NF3, and here present NH3 our ammonia compound. Now our given question is there that we have NH3 and NF3, and we have to explain that NH3 has greater mu value than NF3. Now both are present in tetrahedral structure, both are sp3 hybridization, both have sp3 hybridization because of presence of sigma bond. Now these hydrogen are electropositive, so it's due to its electropositive character, the dipole moment goes to upper direction. And we have also the electronegative lone pair, so its dipole moment goes the upper direction, so our NEET dipole moment goes to the upper direction, so it has the mu value, this is 1.46 dB, because here d value increases. We know that mu equal to E into D. As D value increases, so our mu value also increases. Our second compound is NF3. Here we have 3 electronegative fluorine compounds. Here the fluorine has delta negative character, so the 3 dipole moment goes to downward direction, and we have the lone pair which is less electronegative than fluorine, so it goes upward direction. So basically cancel out, but to comparison the electronegativity of fluorine and lone pair of nitrogen, the power of electronegative fluorine is greater than the lone pair, so the vector of mu value goes to the downward direction. So its mu value decreases, basically cancel out little bit, so mu value decreases and it's maybe mu equal to 0.26 dy. So our NH3 value, mu NH3 value is greater than mu NF3 value. So this is our answer. If the benzene contain two similar compound in 1 and 2 position, this is called ortho. In 1 and 3 position, this is called meta, and 1 and 4 position, this is called para. So from in between three compounds, three similar type of compound or isomer, we have to calculate which isomer contain the greater mu value. Now we see that these chlorine are electronegative. Place 1 and 2, this is nearly a small distance, 1 and 2, so its electronegativity or goes this direction, almost same direction, and its bond angle almost 60 degree. So its distance nearly small, so its mu value also goes this direction. Okay, let us consider the upward direction. So it has, as two chlorine are highly electronegative, so its mu value also greater, so its mu value is 2.68 dy. So this is very large value. Now in the meta compound, the two chloro compound placed in 1 and 3 position, now its bond angle is 120 degrees, so distance between two electronegative chlorine is greater compared to ortho compound, ortho isomer. So its mu value goes upward direction, and another chlorine mu value goes, the vector of mu or dipole moment goes this direction. So here some kind of mu value is cancel out, so its mu value is 1.55 dy. So the value are approximate value. Okay, and we have the para isomer. In this case, these two chlorine present opposite direction and its bond angle is 180 degree. So the dipole moment vector of mu or dipole moment is placed in opposite direction, so basically cancel out, so mu equal to 0 dy. So in between three isomer, ortho dichlorobenzene is greater mu value than meta, then para. Similarly, we also put here in the place of chlorine, we also put here NO2 or OH group or bromine, iodine, fluorine, any kind of electronegative compound. Okay, so the formula is the mu value is ortho compound is greater than meta than para.